Hey Algebra 2, today we're talking about the quadratic formula, and we're going to be dealing with complex numbers. But first, I want to remind you about the quadratic formula. It's, hopefully you have this memorized, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this only applies when everything is on one side of the equation, 0 is on the other. So first thing we would want to do, again I'm just going to do a basic one here, is move the 16 over. So we get x squared plus 6x equals, plus 6x minus 16 equals 0. So here goes, this invisible one is our a, this is our b, this is our c. So the way to solve, actually I'll move it here, x is equal to negative b, in this case negative 6, plus or minus 6 squared minus 4 times 1, which is a, times c, negative 16, over 2 times a, which is 1. So in this case we get negative 6 plus or minus. On the inside we have 36, negative and a negative makes a plus 64, okay, over 2. So now we have 36 plus 64 is 100. And hopefully you remember that the square root of 100 is 10. So negative 6 plus or minus 10 over 2. So now we're left with two possible answers. Negative 6 plus 10, which is 4 over 2. When you divide that is 2. Or negative 6 minus 10, which is negative 16 over 2. When reduced is negative 8. Okay? So this is stuff that we've done before. We're going to do the same thing. It's just now we're going to introduce some complex numbers. So I, the letter I, will probably be in your answer. So this one says solve using the quadratic formula. So just like our last problem, we need to make sure one side is equal to 0. So we're going to add the 2 over. So we get 3x squared plus 4x plus 2 equals 0. So now when I set up the quadratic formula, I get x equals negative b, in this case negative 4, plus or minus b squared, so 4 squared, minus 4 times a, which is 3, times c, which is 2, all over 2a, so 2 times 3. So if we were to clean this up a little bit, we get negative 4, plus or minus, we have 16 minus 4 times 3 is 12. 12 times 2 is 24. And that's going to be over 6. Well, 16 minus 24 is actually a negative 8. So positive negative 8 over 6. Well, like we've been doing this entire time, whenever we're left with a negative underneath, we want to take it out and make it an I. But notice we can also break down 8. Negative 4 times 2, right? We've done that many times. So we could say negative 4 plus or minus, take the square root of negative 4, which is 2i, because we took the negative out, and we're left with 2 over 6. Again, we've done square root of 8 so many times. Square root of 8 is 2 root 2. Now, we notice that 4 and 2 are both, 4, 2, and 6 are all multiples of 2. So we can reduce everything, all these three terms by 2. So negative 4 divided by 2 is negative 2. This 2 reduces to be 1, I, root 2. And then 6 divided by 2 is 3. Alright, so again, it's the same step as before. It's just now that we have a negative, we just pull that negative out and it becomes an I. Okay, same steps. Alright. Only one other example here. This one says find the 3 cube roots of negative 8. So the question is, what number to the third power is negative 8? Well, what to the third power? So if we were to do the third root of negative 8, when we did that with last chapter, you end up with negative 2. But we want to find these roots. So what we're going to do is, when you're dealing with cube, we've done this in the past. Oops, sorry. a plus b equals a squared minus 2ab plus b squared. So we're going to plug in x for a, and we're going to plug the negative 2 in for b. Okay? Sorry, let's switch that up. Let's go ahead and make that negative. There we go. Sorry. Because that gives us a negative 8 when we distribute. So, if I were to plug a negative into so we have negative b, and we said b is negative 2, we get x plus 2, x squared, geez, I'm messing up big time here. This is a squared plus ab. There's no 2 there when you're dealing with cube roots. So now you have plus a times b. A is x, b is negative 2. So a times b, x times negative 2 is negative 2x. And lastly, b squared, so plus 4. Well, now we're going to set both of these parentheses equal to 0. So this one, so we could solve for x. Well, we know here, you just change the symbol, so x is equal to negative 2. There goes one answer. But here's the part where you have to use a quadratic formula to find the other two answers. Because you can't break this up into two parentheses. So, we do x equals negative b. So again, we're only dealing with this right now. Well, b is negative 2, so it's going to be positive 2 plus or minus negative 2 squared minus 4 times a times c. 1, 4. All over 2 times a is 1. Alright. So we have 2 plus or minus negative 2 squared is 4. Negative 4 times 4 is negative 16. We have a root over that. Okay. Well, here we end up with 2 plus or minus the square root of negative 12 over 2. Well, we can't have a negative our answer, and we could break down 12. We could actually break down 12. Again, we've done that one along many, many times as well, which breaks down to negative 4 times 3. So if I were to pull that out, we have 2 plus or minus the square root of negative 4 would be 2i. We're left with the root 3 underneath over 2. And again, if all three of these are multiples of the same number, we could take it out. So since we can divide all of those by 2, 2 divided by 2 is 1. 2 divided by 2 is 1i root 3. So that's how we use the quadratic formula. So when you're dealing with cube roots, again, we're saying what to the third power is negative 8. So this is the setup you want to use for that. So the a minus b, and I'll even show you a really quick one again. A minus b, this is the format. A squared plus ab plus b squared. So if I said find the three cube roots of negative 125, I know that a is equal to x, b is equal to negative 5. So x plus 5, and this becomes x squared minus 5x plus 25. So that's your initial setup. Obviously, you have to do more to solve for x to find the three cube roots, but this is how you would set this type of problem up. Okay, well, good luck with that, and yes, this is how we use the quadratic formula to solve the quadratic equations using when we're dealing with complex numbers. All right, quadratic formula. Memorize that. You should already have it memorized, but if you haven't, memorize it. All right, goodbye.